So we've got this matrix that represents a depth versus time thing, where you got a depth of 150 at time 20, depth of 100 at time 40, depth of 60 at time 90. Okay? And I want to reduce this matrix. Okay? And I want to reduce it to upper triangular form while keeping track of the elementary matrices so I can write down the LU decomposition and then solve the system by LU decomposition, right? Well, that would be the augmented matrix, and you don't solve an augmented matrix by LU decomposition. So first thing we do, and I'm going to switch rows to put the smaller numbers in the first row, which I kind of think might be more useful, okay? Just a little easier to manage, although it's going to be, you know, numbers are going to be kind of a pain. And we multiply this by the x, actually we're using A, B, and C for the parameters of a quadratic equation, right? Quadratic function. And over here we're going to put our depths, 150, 160. So system translates to this matrix equation, and now we have something we can solve by LU decomposition. This is an augmented matrix. Okay? So we reduce this matrix, and I'm going to say, okay, this is going to be 0.05 and 0.0025. And I'm not writing down exactly what I did. It should be implicit. I divided the first row by 400, right? Okay? And the elementary matrix is going to be this. Okay? And the inverse elementary matrix that I'm not going to write down will have the 400. Because that'll take this matrix back to the identity. Okay? Now I assume you understand it because we did this in detail with a couple of examples, listing the elementary matrices and seeing how that's done. If you don't know how to do that, you need to review that. And your book tells you the same stuff. So whatever works for you. My stuff, my videos, the book stuff, your notes, look up elementary matrices online. Just find all kinds of stuff. Find something you like. Khan Academy is always good. But others are too. Okay. So that reduces the matrix to that's 40, not 90. This one's 90. Yes, right? Then we add 1/1600th of the, or negative, sorry, we add negative 1600 times the first row to the second, right? Okay? So the elementary matrix will be 1, 0, 0, negative 1600, 1, 0, 0, 0, 1. Okay? And that's going to give us 1.05, 0.0025, and it's going to give us 0, negative 1600, I got to be a little careful, it's going to be times 0.05 is divided by 20, minus 80, so that should give us negative 40, but again, my arithmetic might or might not be right here, okay? Spontaneous question, as they usually are. And then that is 1/400th, and 16 times that's going to be 4. It's going to be negative 4, so it's going to give me negative 3, I hope. Okay? That, whatever it gives me, is going to look something like that. And that's going to be my elementary matrix. Now, 8100, 91, Okay? This is what I get when I divide the second row by 40. So my elementary matrix will be this. And I divide it by negative 40. So there's my elementary matrix, which when multiplied by this gives me this. Okay? So you see my upper triangular form is coming about nicely. And I have ones here. I'm not going to bother getting a 1 down here when I finally get this row done. But now, we'll complete this. And now, I'm going to divide by 8100. And divide this row by 8100, okay? Now, reciprocal of 8100 is a little tough to do in my head. It's like 0.002, 00024, I think. 0.000, that's not 24, it's 1, 2, 4. Okay? So I think what I need to do in order to do that is something close to this, but I don't have an exact number that I can quickly figure out in my head. If it isn't this, I think it's close. Okay? And actually it's 8100, which is 1 part in 80, it's 1, 2, 3 something. I'm going to go with 1, 2, 3. Just because I know how to count. I've known that many people. 1, 2, 3. Okay. And I'm going to have now 1.05, 0.0025, 0, 1, 0.075. Now I've got 1, and I've got 0.011. That's actually repeating. And I've got 0.000123. Okay? And I don't know why I did that. Because I didn't need a 1 here. Right?
Oh.
I should have multiplied this by 1 over 8100 and added to this, right?
Mm-hmm.
So, you know, all that mental effort. The only thing I did there that I had to really think about was the 0.000123, which I can use, but not here. You do that here. Going to be negative, right? Negative 0.000123 with 1. I could do this with fractions. That'd be negative 1 over 8100, right? Everybody punch that into a calculator? It's okay. I was just curious. I don't need to know. I know it's right. Okay. I don't know about that. So I'm going to get 0 here. And then 0.05 divided by 8100. What'd you get?
Minus 1.234567.
2345. Good. It is 23.
Mm-hmm.
Okay, that's all I needed to know.
Mm-hmm.
Times 10 to the negative 4, right?
Yeah.
Okay. That was really pretty easy. I mean, everybody knows that 1/8 is the same as 0.125, right?
Mm-hmm.
If you know that, then that's really pretty easy. You just have to look at, okay, that's off by a little over 1%, so that's going to be under by a little more than 1%, right?
Mm-hmm.
So there's no deep mental arithmetic going on, just demonstration of a couple of simple facts and the rare ability to have enough working memory to remember what I just said. Okay? So, okay, anyhow, this times that is darn near